So now we would need to think about our normal BGP best path selection rules. So let me bring it back up, my slide that we had talked about previously with that. And that was in core BGP routing, which is what's the path selection order. Okay, first off, we look at, do we have a route to the next hop? In this case, the next hop is the directly connected eBGP neighbors, so that's not going to be an issue. Okay, we then look at the weighting, but that's going to be by default null or 0 if we're not locally originating the prefix. Okay, local preference should be equal as 100. Neither of these are locally originated. It's coming from the same AS path, so basically everything up to this point should be equal. The origin code, both of these should be IGP, because on the other end of the link, we're originating the route with the network statement. The multi-exit discriminator, this may potentially come into play, but from router 3's point of view, it's the same device that's originating the path both ways. So the mid should be equal between these two paths. And let me double check that here. That we're looking at the next hop. Actually, in this case, next hop is inaccessible on this one. So that is a potential problem. What I should have done here is done next hop self between those iBGP neighbors. We could also advertise that inter-AS link into IGP, but as long as we have a route to the next hop, really that's what we care about. So actually, let me make that change before we go on, which if we show run router BGP, was to say for this guy under labeled unicast and regular unicast, we're going to say the next hop is self. Okay, as well for labeled unicast, let's show our config and then commit. Okay, so same thing on the other side. Router BGP 11, 12, 13. Neighbor is 12, 12, 12, 12. And then we're doing next hop self. Okay, so let's look back from XR2's point of view. We should see now that the other path is not inaccessible in terms of the next hop. Okay, so we know how to reach both of these. So we have the next hop. The weighting is set to, should be 0 on both of them. Okay, and it doesn't actually show the weighting, so it means that it's 0. Then the local preference is 100. Local preference is 100. It's default on both. Neither of them are locally originated. The AS path is both 1, 2, 3. The origin code is both IGP. The med is 2 versus 2. Then we say external over internal. Okay, this is where our decision is typically going to be made here. So this doesn't really relate to MPLS. It's just normal BGP routing logic that if the route is learned from eBGP, it means you don't own the route. It's in somebody else's AS. So you should prefer to route out of the AS as opposed to into the AS. That's sometimes referred to as hot potato routing versus cold potato routing. That you choose whatever the closest exit point is versus potentially the most optimal internal path. And that's what this step is doing here, is basically say do hot potato over cold potato routing. Okay, so basically this is the reason now why XR2 is choosing that path. It's that it's coming from the external neighbor. This one is our best path. So let's say that we're going to do a modification to make it go the other way. We now know that we could do a change of anything above this selection in the path order. So basically anything above here we should be able to change and then make the selection move over. Where typically we would want to do this though is where? Or what attribute would typically we want to do this with? Is normally going to be local preference, right? Because if we're trying to affect our outbound path selection, we want to make sure all of the other internal routers agree with that, and local preference is going to be locally significant to the AS. So it means that if we lower the local preference on XR3, it means that XR2 is, or the other way around, if we raise the local preference on XR3, it means that's going to affect XR2's path selection. So let's now say from XR3's point of view that when the route comes in, on the link that we want to use as the primary, that we're going to set the local preference to higher. Let's say we're going to set it to 200. So we're going to need to do this in our routing policy. So on XR3, let's say that we're going to create a new RPL. We'll say route policy, and this is, we'll say in from router 3. And we will say if the destination is in 1111/32. No, this is what? 2222. 2222/32, then set the local preference, and we'll set it to be higher. Okay, else we're simply going to pass. Okay, then exit. Okay, so next we're going to apply this in from router 3. So if we look at the show run, do show run router BGP, this is going to be applied as the labeled unicast policy inbound. Okay, so we're going to say that the route policy is now in from router 3 in. Commit the changes. If we look at the show BGP IPv4 labeled unicast, we now see the local preference has been modified. Okay, if we look at from XR2's point of view, where the best route was the external path, we should ideally now see it move over to the internal path, which it is. Okay, let's now look at this from the forwarding point of view. So we go to router 8, and we do a trace. Now we can see we're going from 12 to 13. Now we have another potential issue, though, that when we modified the path selection to the next hop, it's going to affect all other customers that are located on that particular provider edge router. So from from router 8's point of view, we do the trace to 10, and we can see now we're going from 12 to 13. But if we do the trace from 4, we're still going to go to 12 because these final destinations had 2 separate next hops. One of them was going to 2, one of them was going to 3. But from router 3's point of view on the other end, both of the next hops are XR1 because this provider edge router is hosting both of these VRFs, that we have VRF A over here and VRF B over here. So in other words, that if we're trying to change the path selection just to A, we can't do that from router 3, that it's going to affect B as well by default. Okay, so let's say that we're going to go to router 3, and we want to prefer to use, let's look at how is it currently choosing the route. Let's look at this will be from 10's point of view. 10 is going from 3 to 12. Okay, this should also be the same as what 7 is doing, from 3 to 12. So in router 3, if we look at the show IP BGP, we can see that we have 2 different paths to get to the destination. And if we show IP BGP for 11.11.11.11/32, it says that the best path is via 12. Okay, so let's look at this from our path selection point of view again. Why are we choosing this path over the other one? So first off, we look at the next hop. Okay, we know how to reach both of these. The weighting is not set. Local preference is both 100. Neither of these are locally originated. Okay, the AS path is going to be the same because it's coming from the same AS, okay, 11, 12, 13. The origin code is both IGP because they're using a network statement on the other side. Now we're looking at the metric. Okay, the med in this case is 10 versus 20. The reason why is that both of these edge routers are originating the route from IGP into BGP, so they're automatically copying their ISIS metric into the BGP update. So in other words, they're signaling to the remote AS that I want you to use my shorter internal path because XR2 is closer to XR1. So now we know that if we were to modify path selection, it would have to be something at med or above. Okay, so let's say we're going to do it with the same way we're going to do it simply with local preference, because this is going to affect all of the devices within our AS, But we could likewise do it the other way around, where we could do a policy that goes from XR2 out or XR3 out that is doing either AS path prepending or changing the multi-exit discriminator. But the key point here is that you need to know the path selection order, because if you don't know why the prefix is choosing one path over another, then you don't know where in the decision process you could actually make the change. Okay, but what I'm going to do here for simplicity is just go to let's say route map local. Actually, let me do this. What I'm going to do is to say, I'm going to make this more specific. I'm going to say IP prefix list 11 permits 11, 11, 11 /32. Then we have a route map that is going to be in from XR2 that says to match IP address prefix list 11 and set the local preference to 50. Okay, so this is basically going to be our less preferred path. Okay, then we're going to just permit everything else. Okay, so we have the route map says permit 20. So let's do show run pipe section route map or prefix list. So if the prefix list is true, set the local preference to 50. If the prefix list is not true, then you're not going to modify anything. Okay, we're then going to apply this under the BGP process. So let's show run section BGP, and we're going to apply this in from 12. So it's under address family IPv4 unicast. So neighbor, the route map is going to be in from XR2 inbound. Okay, these are global unicast routes, so we're going to say just clear IPBGP star in. That's going to do a route refresh. And if we show IPBGP, we now see that we have a local preference of 50 versus the default, where the default is 100. So if we now look at this from the customer router's point of view, which is from router 7 or router 10, we should see that our path selection is going to change, that we should go over to router 13, okay, which we did. Okay, so we're going 3, 13, 12 as opposed to 3, 12. Now the same should be true from 10 because it's going to the same PE router, that it goes from 3, it was going from 3 to 12, now it's going from 3 to 13 to 12. So from the other way around, since there's two separate provider edge routers, we can make separate decisions on the next hop values, but it makes it a little bit more complicated in this case because from router 3 out, we're terminating the LSP on the same address on XR1. Basically for both of the VRFs is what I mean. But let's say we don't want to do it this way. Let's say from XR or from router 3's point of view, that when traffic is coming from 10, okay, 10 is in VRF-B, so it's B to B and A to A. That when traffic comes in from A, we want to go this way. But when traffic comes in from B, we want to go this way. What would be some of the potential ways that we can modify this on router 3 then? Or just in general, not necessarily on 3, but what are the different things that we can change in order to allow this to happen? Okay, and it goes back to what we were talking about, just the core functionality of VPN v4 BGP, that the next hop determines what the label switch path destination is. So from XR1's point of view, when it's advertising both of these VPN v4 routes, they're going over to router 1. Router 1 is then reflecting it and it's not modifying the next hop. So router 2 and router 3 are going to see the next hop as 11, 11, 11, 11. That's what they're label switching towards. But how does it know to do that to begin with? How does XR1 know that when I send the VPN v4 update, that I'm supposed to be sending it from 11 as opposed to sending it from, let's say, this connected interface? So let's look at XR1's config. If we look at under BGP, what's actually determining that? The update source, right? So one of the next questions we would need to think about is, well, how many peers are we going to? In this case, there's only one other peer in the remote AS, which is router 1. So we can't change it to two separate update sources with the BGP session. But the key is that there's a separate variable here that controls on a per VRF basis what BGP next hop that we're going to use when we do those advertisements. In the case of regular iOS, like if we go onto router 3 and we look at the show run VRF, this is going to go under the VRF definition, and we would say under the address, or is it the IPv4? No. Address family, IPv4. It is the BGP next hop. Okay, by default, the BGP next hop is going to be whatever your peering address is coming from. But the key is that you can change this. So you can say on a per VRF basis, I want one VRF's VPN v4 updates to use loopback 0. I want another one to use loopback 1. This means that I now have two separate tunnel destinations that I can do BGP best path selection separately between them and now control the traffic for one customer separately than another. Now, another way that we could do this is also with MPLS traffic engineering, that you could point the tunnels at different loopbacks. You have one TE tunnel for one, a different TE tunnel for another. But we'll talk about that in more detail when we actually go over regular MPLS TE with RSVP. But in terms of iOS XR, if we look at the show run VRF, I want to change the update source for what? I want to change the update source for B. So let's say that under VRF B, the no, not the VPN ID. Let's see, is this under address family IPv4? Unicast. Let's see, maybe this is under the BGP process. Let me abort here. Let's say show run router BGP. And let's go under router BGP 111213. VRF is B. And then we'll say the BGP let's say, is it under the address family, IPv4, unicast, next hop. Next hop resolution, no, that's for next hop tracking. BGP, so let's see, let me check the, let's go to the command reference under the VRF config. It should be under, I'm going to say this is either under the VRF config or under BGP. So let's go to release 5.2. VRFs would be under what, interface and hardware, or under routing? Let's see, changing, we're going to cheat here. Changing next hop of a VRF in iOS XR. Associating a VRF with the next hop. Implementing BGP. Let's search for next hop. Wonder maybe we need to do this under RPL. Let me see if we can. Let me try this. Let's say we create a route policy. And we'll say that this is next hop that says if what would we need to match on? We would need to match on the route distinguisher. Well, no, technically the route distinguisher is the same, so we would need to say I don't know, the route distinguishers are different, right? Let's say do show run router BGP. The distinguishers are different. Okay, so let's say if the RD is in 200:200, then set the next hop to 111.11.11.11, else to pass. Okay, so let's commit this change, and then I'm also going to need to advertise a new loopback. So let's say we have loopback 1, IP address is 111.11.11.11/32. And if we show run router ISIS, we're going to need to advertise this into IGP. So under ISIS, we'll say loopback 1 is passive. Okay, address family is IPv4 unicast. So if we look on the other end, if we go to router 3, we should, once IGP converges, we should see 111.11.11.11. And I need to advertise this into BGP on the other side. Okay, so if we show run router BGP, we need to advertise it here, okay, under IPv4 unicast. Okay, same thing on the other end. So we go to XR3, router BGP 11.12.13. Okay, so now let's see, from router 3, we should be learning this new next hop, okay, which we are. Okay, now let's say on XR1 that as we advertise VPN v4 routes out to router 1, we're going to send it through this RPL, and the RPL should be able to modify the next hop, but based on the route distinguisher, and the route distinguisher is then bound to the VRF. So if we show RPL, this is going to be our next hop policy. If we look at the show run router BGP, this is going to go under this neighbor to router 1. Okay, so this new route policy is going to be outbound to them. Route policy is next hop out. Commit the change, and then let's clear BGP VPN v4 unicast star soft out. Okay, if we now look at this from router 1's point of view and show BGP VPN v4 unicast all, we should see now that there's a new next hop. Okay, I'm not 100% sure if there's a shorter way to do this in XR. I'll have to double check if there's a command that does it. But the key is that it's just a normal BGP attribute. You can change it like any other thing that you can do in best path selection. So if we look at this now from router 3's point of view and look at the show BGP VPN v4 unicast all, we should see that and let's see, it's actually not 3 that's making this decision. It's going to be 2 that's making this decision. So show BGP VPN v4 unicast all. It says I need to recurse to 111.11.11.11. So we show MPLS forwarding table for 111.11.11.11. This goes out towards router 3. Okay, router 3 is then going to say the same thing. And it says, how do I get this to this? It says I go to 12, because if we look at the difference between the 11 and the 111 address, these now have 2 separate BGP best path selection decisions. The one that I had modified with the route local preference is the one that's going to 13. The one that has the default best path selection, which was the lower med, is going to 12. So what this should now mean is that if we trace the path from 10 to 8, that we should be going not from 3 to 13, but we should be going from 3 to 12. So it's kind of a roundabout solution, but the point is that when you're looking at the inter-ASL3 VPN config, the path selection is not really based on the final route. The path selection is based on the next hop. So you would need to change regular IPv4 unicast path selection, look at how do I recurse to the next hop and what label am I using. That ultimately controls how the outbound traffic towards the labeled destination is going to go. Okay, so again, in regular iOS, this is kind of a simple change because it's only one command, which is, it was under the VRF, like VRF definition A, and then it was under address family IPv4, and it's the BGP next hop. Okay, in the case of XR, the way that I did this was to create a routing policy. If we show RPL, it was to say if the route distinguisher is 200-200 in the BGP update, then change the next hop. This was applied to the VPN v4 neighbor outbound, and then it means that it's going to affect the actual labeled traffic as it comes back inbound. Now, there's one other quick point that I want to mention here that is kind of a pitfall that you have to watch out for in regular iOS. Is let's say that in our our first path selection example where we were going from router 8 to 10, and we changed path selection where we were going 12 to 3, then we changed it go to 12 to 13 to 3. And the way that we did this was by changing local preference. Okay, we changed local preference on XR2 if we look at the show RPL. And actually we did it on XR3. Let's show RPL. Okay, we said if the traffic came in from router 3, or the route came in from router 3, and it's this prefix, set the local preference to 200. Okay, otherwise we're going to pass it. Okay, if we now look at this from a regular iOS point of view, let's say we're going to roll back this change, which is we're not going to use the same policy in. Let's say show run router BGP, and I'm going to say that I'm going to use the pass in policy, which goes back to not modifying anything. Okay, so we should now see that we go back from 12 to 13 to 3. We should go from 12 directly to 3. Okay, so 13 is edited out of the path.